This is Professor Pelton. This is part 4 of chapter 5, section 1. So now we'll do min and max as if it's already in vertex form. So if it's in vertex form, then this is our h and k, right? So that tells us, since this is a negative a, right, it's our a value, this goes down. So our vertex is negative 3, comma 4. So the location is negative 3, 4, and 4 is the maximum, right? The domain and range, so domain and range. We know all quadratic functions go forever left and forever right. This one goes down forever, but since it has a maximum, it stops at 4, which is the max. Okay, well, let's say that we're in the factored form, otherwise known as the intercept form. Okay, well, this one's negative, so that means it still goes down because that's our a value, right? Oh, I don't know why I put points there. Okay, so our h and k, right, h and k, this is clearly a maximum, which is going to give us a domain and a range, right? So we know the domain, and we know the range goes up to a certain value, but goes down forever. Okay, so we know that the intercepts are at negative 3, so negative 3 comma 0, and at 1 comma 0 based on the intercept form. Okay. Whoops. So halfway in between that is the h value, right? Or you can do the formula. It's up to you. So halfway between negative 3 and 1, right? So negative 3 plus 1 divided by 2 will give us the h value, right? So that's negative 2 over 2, so negative 1 essentially, right? Is halfway in between. So if I plug that in, I'll get the k value, right? So k equals f of h. So negative 2 times negative 1 plus 3 and negative 1 minus 1. So I get negative 2 times negative 2. So we get what? Positive 8, right? Okay, so this has a maximum value of 8. All right, pause the video, try the student problem for yourself. Or student problems, plural, I should say. Okay, so first the easier of the two. So it's already in vertex form. So that's my h and k, and this is a positive a value. So this one goes up, right? So I have a vertex right here, which means this is a minimum. So my domain and range, I go forever left and forever right. And I'm going to go forever up, but I'm going to down to a certain value. I'm going to figure out what that is. So my vertex is 2, negative 4, right? So I'm going down to negative 4 essentially. Okay. All right. So let's try the intercept form, or what's called the factored form, which is called intercept form. Okay. So in this case, the 1/4 is positive. Okay. So that means that's the a value. So that means this is going up. So that means I have a minimum. Well, the coordinate has a minimum, right? And I have x-intercepts here at 2, 0, and 6, 0. Again, I can multiply it all out and do the h formula, but I'm not going to do that because I know that halfway in between 2 plus 6 divided by 2 is 8 divided by 2 is 4, right? So 4 is halfway in between, right? So that's my h. So you got to figure out my k. So k equals f of h. So basically f of 4, right? So 1/4 times 4 minus 6 and 4 minus 2. So I get 1/4 of times negative 2 times 2. So essentially I get negative 1. So domain and range, I go forever left and forever right. I'm going to go down to -1 and then up forever. Okay, let's go the other perspective and look at graphs. Okay, well, if I have a graph and I want to make the equation, I have three starting point choices if I go back to the original first page, right? So on the original first page, okay, we have the intercept form, which is basically the factored form, right? So if I have the x-intercepts, that one's a good form to use. If I have the vertex, this one's a good one to use. And I want to put the answer in the general form when I'm all done, which is when you multiply it out and distribute it all out and add like terms. They just go in descending order. Okay? Okay, so those are my three forms, which I've been using all along each of these sections. So now I'm going to go to the graph and choose what's the easiest. Well, these x-intercepts are clearly not very nice, and who knows what they are. They're point something and -4 point something, who knows. But I do in fact know the vertex, which is -2, comma, -3. So that's definitely my h and k. So I think vertex form is the way to go. So y equals a x minus h squared plus k. Okay, so y equals a x, and then minus the h is a -2 squared, and then the k is a -3. Okay, so I need an x and y value from the graph. Any coordinate is fine. So any coordinate on the graph is fine whatsoever. So just pick something easy. So I'll pick this coordinate right here, which is 0, -1. Okay, that gives me a random x and y. It doesn't matter which coordinate you pick, you'll always get the same answer. Okay, so if I plug that in, -1 equals a 0 plus 2 squared minus 3. So -1 equals a times 4 minus 3. Okay, so I'll add 3. So 2 equals a4, or 4a. So I'll divide by 4. So a is 1/2, which is not my answer. That's asking for a general quadratic form equation, right? So I have y equals, my a value is 1/2, x plus 2 squared minus 3. Okay, so that is the function, but it's not in general quadratic form. So I'm going to multiply it out now. So I do exponents first. Then I'll multiply. I think I'll multiply the x terms first. Okay, so I'll multiply one more time. So I get 1/2 x squared plus 1x plus 1x plus 2 minus 3. Oh, 2x. No, it's just plus 2. Okay. So we did exponents, then we did multiply, then we'll do add and subtract. So 1/2 x squared plus 2x minus 1. So that is the general form. So this is a valid answer. It's just not in general form. Okay. All right. Pause the video. Try the next one for yourself. Okay. So based on what's given here, since I have x-intercepts, right? Probably the intercept form or the factored form is the best one, right? So y equals a. I think I did p and q with the letters. I believe that I did. Okay. So y equals a. So I'm going to do a bracket here and do -1 minus root 3 minus p. And -1 plus root 3. Oh, why did I do p? I'm sorry. That's the p and q. I messed that up. I'm sorry. Not thinking here. All right. So x minus -1 minus root 3. And then x minus -1 plus root 3. Okay. So we need to figure out the a value. So I needed some kind of coordinate first, which I gave you one coordinate here, which is fine. Okay, so we'll plug that in. So 2 equals a, and then 1 plus 1 plus root 3. And then let's see here, we do 1 plus 1 minus root 3. Okay, So 2 equals a. So we have 2 plus root 3, and then we have 2 minus root 3. Okay, so let's multiply that out. So 2 equals a. So I get 4 minus 2 root 3 plus 2 root 3 minus root 9. So 2 equals a times 4 minus 3. So basically, a is equal to 2 because that's 4 minus 3 is just a 1 essentially. Okay, so if I rewrite my equation now, y equals 2, and then we have our brackets here. So we have x plus 1 plus root 3. Let me make that a better plus. And then x plus 1 minus root 3. Okay, so I'm just taking my equation right from here, but now plugging in the a value. All right, so that is actually fine, except it's not in general quadratic form. So I have to do a little math here. So y equals 2. So if I multiply this out, I get x squared plus 1x minus root 3x, right? And I go underneath, I get plus 1x plus 1 plus, minus root 3. And then I go to the last one, plus root 3x plus root 3, and then minus root 9. Okay, so you notice a whole bunch of terms cancel out. Okay, so the x squared stays the same. And if I look at my colors here, that cancels with that one, correct? And then this one cancels with that one. So I'll go back to the blue now. So I have a 1x and a 1x, I get 2x. And then I have a 1 and a minus root 9, which is minus 3, so that's really a minus 2, correct? So my equation ends up being 2x squared plus 4x minus 4. Okay, and that is the end of part 4.